Are you able to view my desktop now? Okay, great. So in today's class, we are going to start with SSAS SQL Server Analysis Services. Okay, we are going to use SSAS module to create OLAP cubes. Okay, so why we are going to create OLAP cubes? Because if you go to the very beginning session, whenever we have typical questions like what are the top 10 products which are performing well in the specific region on the fly, so by simply dragging and dropping the dimensions and facts, if you want to get the ad hoc results on the fly, then always it will be very helpful if you create the OLAP cubes. Okay, so OLAP means online analytical processing cube. OLAP, see here it says OLAP DB, database structure. So the database structure is multi-dimensional database. So generally if you create any database, we are going to use RDBMS structure, right? So relational database management system. That means the data will be stored in the form of tables, entities. But here, when you say OLAP cube, online analytical processing cube, the data will be in the form of cube structure. Cube in the sense, data will be separated into dimensions and measure groups. Okay, so cube is nothing but a collection of dimensions and measures. So for ad hoc reporting, for analytics purpose, we are going to create OLAP cubes. That is the reason why by simply dragging and dropping, we will be able to answer very typical questions on the fly. If you want to write SQL query for the same kind of questions, it will take a lot of time, and in order to execute the results also, it will take a lot of time. So that is the main advantage of OLAP cubes. And also we have ability to create hierarchies, drill down, roll slicing and dicing. We can roll up the data. So a lot of advantages are available in the OLAP cubes. Finally, you can create the reports out of the OLAP cube using the SSRS again. So these are the main advantages of OLAP cube. So let's see what is OLAP cube. Okay, so let me give you a simple example here. If I go to the cube structure, see, I told you cube is nothing but a combination of dimension tables. So we should not call them table, rather than we call it as a dimension. Okay, so dimensions, collection of dimensions, and measure groups or fact table. Okay, so here I have drawn a simple cube structure, but in order to understand that, I tried to represent it as a cube, but not exactly the data will be stored like in the cube format. So it is also like a table format only, but the collection is like dimensions and measures. Okay, so here I have taken 3 dimensions and 1 measure. So the first dimension is uh, geography dimension, because it is talking about country information. Okay, so before starting with this example, let me give you a small introduction to the keywords. Okay, whatever we are going to discuss here. So generally in RDBMS we will have tables, right? Okay, tables will have columns, isn't it? Table is a combination of columns and rows, right? So columns, and we will have rows. So rather than, I can call it as a cell values, right? Cell values. That means each and every cell will have some value, right, in a column, correct? So the combination of multiple columns is nothing but a row horizontally. Here in SSAS we call it as dimension. Okay, columns are nothing but attributes. Clear? So rather than calling the column, in dimension we will have attributes. Now each and every attribute will have some attribute values. Sorry, attribute members. Attribute members. Okay. So if I give you some example, let us say we have a table called time dimension. Okay, time dimension. So time dimension is nothing but a timetable. In time dimension, we have columns called year, quarter, month, day. These are all columns. So we are in SSAS, that's why we call it as a attributes. Clear? Attributes. So year one attribute, quarter is one attribute, month is one attribute, and day is one attribute. Clear? Now whatever data that is available under year, so some data will be available, right? What is that data? Let us say 2005. Okay, 2006, 2007. These are all years information that is available under year attribute. So these are all called, these values are called what? Attribute members. Attribute members. Clear? So I think you understood the terminology. So table is nothing but a dimension. Year, quarter, month, day are nothing but attributes. Whatever data that is available under those attributes are nothing but attribute members. Clear? Any doubts so far? Fine. Now we have to talk about one more concept here. Hierarchies. I told you, right? That is one more advantage. We can create hierarchies in the OLAP cubes. Hierarchy. What is hierarchy? Hierarchy is nothing but relationship among attributes. I told you what is attributes. Attributes are nothing but columns that are available in a dimension. So relationship among columns is nothing but a hierarchy. Relationship among attributes is nothing but a hierarchy. Okay. So without hierarchy, without attributes, you will not be able to create hierarchy. In a dimension, there should be attributes should be available. Otherwise, you will not be able to create a hierarchy. So let us say in your time dimension, you have year attribute, quarter attribute, month attribute, and day attribute. Okay. For example, if I want to summarize the data at year level, year wise product sales, if I want to check in the report, then what I will do, simply I will drag the year hierarchy so that I will be able to see the year wise summaries. Okay. In 2005 this particular product sales is this much, 6 this much, 2007 this much. So year wise sales amount it is going to show you. If I want to further dig into that information, that means if I want to deep dive into the year information, then I will click on that plus symbol beside to the year. Just like we are doing drill down reports, right? In SSRS. How we did it? We created the groups. And especially for matrix reports, we have taken year as a column group. Under year, again quarter. When you click on quarter, then again month information. When you click on month information, finally you will get day information, day wise sales. So year wise, quarter wise, month wise, then day wise. So in hierarchies also, I will take year, I will take quarter. Let's keep like that. Okay. Then month, then day. So in hierarchies, I'm going to take the existing attributes year, quarter, month, day, and I'm going to create a relationship among all these 4 attributes. It is not necessary that you have to take all the available attributes from the dimension. If you want to remove this month, yes, you can do it, but generally people will not do like that. People will take all the attributes and they are going to create a hierarchy. Now if I want to see the detailed data by clicking on the plus symbol, simply I can create a one hierarchy with the available attributes. Then I can click on the year so that I will be able to see the quarter information. When I click on plus symbol of quarter, then I will be able to see the month information. When I see the day information, this is the lowest level, isn't it? So after this level, we do not have next level. So this is the lowest level, and we call it as a granularity level. Okay, we, we call it as a granularity level because lowest level in the hierarchy. Now in dimension, year is called as attribute. When you come to the hierarchy, this is called hierarchy level. You need to understand the keywords. That's the reason why I'm stressing more on this part. See, quarter is one hierarchy level, like that. Month also one hierarchy level. Okay, now day also one hierarchy level. Clear? In hierarchies, year is one hierarchy level, quarter is one hierarchy level, month is one hierarchy level, day is one hierarchy level. Day is the lowest hierarchy level, that's why we call it as granularity level or detail level. Simple. Now whatever data that is available under year, like 2006, 2007, 2008, this is hierarchy level member. Clear? Here we call it as attribute members, right? Whatever data that is available under year attribute, that is nothing but attribute members. Whatever data that is available under quarter attribute, those are called attribute members, like Q1, Q2, Q3, Q4. Like that, whatever data that is available under year hierarchy level, those are called hierarchy level members. Simple thing. So any doubts so far? Is it clear? Right. Now the important point is we have talked about attributes, attribute members, hierarchies, and hierarchy levels, hierarchy level members. Fine. Let's talk about measures. Okay, we can call it as measures or facts. Generally we call it as fact table. Okay, dimension table, fact table, right? So what is measure and what is fact? Let us say if you purchase any product. Okay, so you purchased one product from a retail store. Lot of information will be associated with that particular transaction, isn't it? That is one transaction. You purchased a product, so that is one transaction for you as well as for the seller also. Seller sells a product to you. So what is the product ID? What is the product name? How much you have purchased? Quantity? What is the unit price? At what price you purchased that? And how much is the total sales amount? Quantity multiplied with the unit price. And at what time you have purchased it, at what store you have purchased it, what is the store location, what is the country, state, city, what is the store ID, okay, at what time you have purchased that, who is the customer. Sometimes they are going to retail, especially retailers, they are going to maintain the customer information also. For small products they might not uh, provide all this information, they might not take the customer ID information. If you purchase some big items, then they are definitely going to maintain customer information also in order to do the analytics on that data. Okay, so they are going to take the customer gender information, with married or single, so they are taking the personal information also, like married or customer is single, whether male or female. what is their address. Okay, so in order to understand their customer behavior, they are going to expand their product, they are going to expand their product base based upon the customer behavior and the customer satisfaction levels. So they are going to do all these analytics, and they will introduce new product mix, okay, new product categories. So what type of customers are purchasing more products and all. So that is the reason why they are going to take all this information. Okay, so whatever information that is associated with that particular transaction, it will be stored in some databases in backend. Fine. So we are going to use that for analytics purpose or reporting purpose. Fine. Now here the information that is related to the numerical values, like I told you, order quantity and sales amount, right? Because these values are these values can be expressed in terms of numerical values, quantity and sales amount. Okay, while purchasing, if you find out any discount from the seller, okay, and if you pay any tax, okay, so these are all related to monetary aspects. These are all can be expressed in terms of numerical values. These are called measures. Simple. So these are called measures or facts. Clear? So I purchased a product. What is the quantity and what is the sales amount? That can be expressed in terms of numerical values. So I can say quantity and sales amount both are measures or facts. Now, what product you have purchased? Product ID, product name. To which category that product is belongs to? Product category or subcategory. This information is related to dimensions. Okay, product name, product ID, color, product price, even price also can be comes under measures, because price is a numerical item, right? So color, model, isn't it? Customer, gender, customer ID, gender, marital status, and at at what location this particular transaction happened, that country, state, city, at what time this particular transaction happened, that year, quarter, month, or that particular day. See, all this information is related to dimensions. So if you take that example, if you take that transaction as an example, so the data that is associated with that particular transaction can be classified into two things. One is measures or facts, another one is dimensions. So under dimension, you will take all the information except the numerical values. Only numerical values will be considered as a measures that can be associated with the monetary aspect. Clear? So what is dimension? Dimension is nothing but it is used to describe the measures or facts. What is measure? Measure is nothing but any value that can be expressed in terms of numerical values, that is measure. Now your cube, your OLED cube will be a collection of dimensions and measures. Simple thing. Your OLAP cube is divided into two parts. One is dimensions, another one is measures. So these measures are simply numbers, but you cannot understand these numbers without the dimensions. Okay, without taking the help of dimension, you will not be describe these numbers. You will not be able to analyze these numbers from different points of view. You can analyze these numbers with the help of dimensions. If I want to analyze sales amount for the past 1 year for the top 10 products, then I will take the help of year dimension. Sorry, time dimension. Under time dimension, I will get these attributes: year, quarter, month, day. So if I want to check country-wise sales information, in which country the products are performing well. So I will take the country, state, city attributes available in a geography dimension. This comes under geography dimension. Okay, I want to check whether the female customers are purchasing more or male customers are purchasing more. I will take customer dimension, customer ID, customer name, gender, their marital status. This comes from the customer dimension. What type of products? Category wise, if I want to analyze the products, what are the top 10 products in the top 10 products which are performing well in the market, that too in a specific category? I will take product dimension. See, this product dimension will have product ID, product name, color, model, something like that. So in our example, we are going to build one measure group that is called fact internet sales. Fact internet sales. This is our measure group, and we are going to design 4 dimensions. Okay, first one is product dimension, time dimension, customer dimension, fourth one geography dimension. Simple. So any doubts so far? We are going to design this one fact table, 4 dimensions. Any doubts so far? No doubts, right? Now, so let's talk about this example. See, same thing I have explained here, but here I haven't taken multiple attributes. Per dimension I have taken only one attribute in order to explain here. See, there are some numbers here, 60, 40, 50, 100. These numbers are nothing but order quantity. See, order quantity. That means only one measure we have here. Quantity is our measure. Okay. Now, first dimension is geography dimension. Under geography dimension, we have one attribute called country. So that country will have 3 attribute members: US, UK, Canada. These are all attribute members. Okay. Now, if I want to analyze this information, see, one more dimension is also there. This dimension shows bikes, accessories, clothing. Bikes, accessories, clothing are related to the product dimension, and the attribute is category. We understood, right? So bikes, accessories, clothing is the information available to category column, correct? So in product category table. Now, like that, we have one more dimension. This is time dimension. In time dimension, we have one attribute called year. Year is having 3 attribute members: 2001, 2002, 2003. So if I go about the 60, what is the 60? 60 is the order quantity. So these many bikes were sold in the countries US for the bikes category in the year of 2001. So we will be able to analyze this information like this with the help of different dimensions. If these dimensions are not available, we will not be able to describe this value. It doesn't have any value. Simple, right? So if you go to the example here, see, dim time is a dimension, year is an attribute, 2001, 2002, 2003 is an attribute member. Like that, dim product is a dimension, category is an attribute, bikes, accessories, clothing is an attribute members. This is the data available in category. For dim geography, country is the attribute, US, UK, Canada is the attribute members. So 3 dimensions are there. Now, measure group. Fact sales is the measure group name, and sales amount, order quantity. These 2 are called measures. I told you, right? See, these are all measures. We call it as facts or measures. Okay, this is one measure, and this is one measure, and this is one measure. This is one measure. Now, how about the data that is available under quantity like 1000, 2000, okay, or 3000, quantity, actual quantity values. These values are called what? Measure members. So in attributes you will have attribute members. In hierarchy levels you have hierarchy level members. Like that in measures you have measure members. That is what mentioned here. See, measure group is fact sales. Measure group will have measures. Sales amount is one measure. Order quantity is one measure. Whatever data that is available under the sales amount is nothing but measure member. Whatever data that is available under quantity, that is measure member. Clear? 1000, 2000. Hierarchies. We have already discussed this. See, in time dimension, we have attributes. With the help of attributes, we have created a hierarchy. The hierarchy name is time hierarchy, under which year is one hierarchy level, quarter is one hierarchy level, month is one hierarchy level, and day is one hierarchy level. The individual data, that is 2001, 2002 hierarchy level members, quarter 1, quarter 2 hierarchy level members, like that. Clear? Any doubts? So this terminology should be understood. That is the reason why I have taken so much time in order to understand this. Okay, right. So let's go to the dimensional modeling. So in RDBMS we are going to follow ER model, entity relation model, in order to design the database and tables. Okay, but here while creating the OLAP cubes, we are going to follow dimensional modeling technique. Okay, in dimensional modeling technique we have two types of modeling, two types of models are available. First one is star schema. So we are going to design the OLAP cube based upon either star schema or snowflake schema. One more schema is snowflake schema. So first of all, let us see what is star schema. See, blue colored one, the center table, that is nothing but fact sales. This is your fact table, and one fact table is surrounded by multiple dimension tables. See, dim product is there, dim store is there, dim date is there. Three dimensions are there. Okay, one central fact table is there, and it is surrounded by multiple dimension tables, and those dimension tables are not connecting to another dimension table. This is rule. This is called star schema. Okay, so this dimension table is only connected to the fact table. That's it. It is not connecting to any other dimension table. Clear? So this is called star schema. It looks like a star. Then what is snowflake schema? If any dimension table that is depending on another dimension table, that means if it is having relationship with another table, then that is called snowflake schema. So exactly it looks like a star schema, but dimension table can be connected to another dimension table, then that is called snowflake schema. See, if you go to the next picture, see, one fact table is there, four dimensions are there, looks like a star, but this dimension table is connected to another dimension table. This dimension table is connected to another dimension table. Clear? So this is called snowflake schema. Clear? So multiple joins are there. So how we are going to join them? Based upon some column, right? See, here we have dim store. In dim store we have a primary key column called ID is there. In fact table, only numerical items are not available. Along with numerical items, you will have foreign key columns also. Otherwise, how you are going to make a join between both dim store and fact table? If I want to analyze store wise top 10 products sales, then how would I get this information? Store wise, how can I get the unit sold information? The moment I have the store ID, this is the foreign key column, this is store ID. So the store ID is connected to the primary key column called ID in the dim store table. Same thing with the dim product. See, here we have product ID. For dim date we have date ID. Clear? So based upon those relationships we are going to get the data from all the tables. So these are the modeling techniques. So let's go ahead and create the project. Let me open SSDT in Visual Studio. We are going to click on new project. Let's select the analysis services. Let me save this project in SSAS. Select folder, provide the name. Select the first one, multidimensional model, UDM model. Let me provide name something like SSAS class 23. That's it. So click on OK. See, the moment you click on OK button, it is going to create one project for you. The project name is SSAS underscore class 23. And here we have data sources, data source views, cubes, dimensions, mining structures, a lot of things are there. So data source is nothing but it is a connection manager, isn't it? So while creating SSRs also, we have created the data source. What is the server and what is the database, isn't it? We need to tell the system from where you want to extract the source data. Right click on it, new data source. Let's create it. Click on next. See, already AdventureWorks is available here. AdventureWorks DW2012 is available. If it is not available for the first time, then click on new, provide the server name, select the database here, AdventureWorks. Okay, so provide your server names like Sudhakar, select your DW2012 database and click on test connection, then click on OK. Then that will be created here. So already it is there. Let me cancel it. So I'm taking AdventureWorks DW2012, then click on next. Select use service account, click on next. AdventureWorks DW2012. So this is the data source name. So let's click on finish. See, it has created a data source. Now once you are connecting to the database and the server, you have to execute some SQL statement, right, in order to get the data. In SSRS also we created the dataset. In dataset we will have SQL statements, right? Like that, here we need to select data source view. We need to create data source view. So in order, when we are going to build this data source view, we have to apply these structures, star schema or snowflake schema. So it depends upon your requirement and all, that structure will be built. So let me right click on data source view, select new data source view, click on next. See, already I have created this data source, right? So that is going to be shown here. Select that, click on next. Now I told you we are going to design 4 dimensions and 1 fact table. Okay, so in order to build these dimensions and fact table, we will take the help of some tables in the AdventureWorks. Okay, so this is just like a real-time data only. So we are going to take the help of dim product in order to build the product dimension, first dimension. So let me take dim product, click on this arrow button, and dim product category, dim product subcategory, these two also required in order to build the product dimension. Okay, so category table will have category information, subcategory table will have subcategory information. These 3 tables related to first dimension. And second one is time dimension. So we have a dimension called dim date. So dim date table, let's take it. And the next dimension is what? Customer dimension. So we have a table called customer, dim customer. So let's take that. And we have geography dimension. For geography also we have geography dimension. See, dim geography. This is the source table. Okay, so we are done with the dimensions. And how about fact table? So I want to take fact internet sales table here. Okay, so total 8 tables are there. Sorry, 7 tables are there. So using these tables, we are going to build the dimension model first. Then we will create dimensions and cubes. Okay. So let's click on next. Now provide any name underscore DSV. That means data source view. So I'm providing name to the data source view. Click on finish. The moment you click on finish button, it is going to show you view, designer view. This is your schema. This is your schema. See, all the tables are connected here. One fact table is there. These are all dimension tables. Now tell me what type of schema it is. Any idea? See, one fact table is there and it is surrounded by multiple dimension tables. Okay. If no dimension table is not connected to another dimension table, then we call it as a star schema. If any dimension table is depending on another dimension table, then we call it as a snowflake schema. Here, this is the only one fact table. In this model, this fact table is connected to dimension tables. This is fine. But again, dim product is one dimension table. This is depending on another dimension table called dim product subcategory. Again, dim product subcategory is depending on dim product category. So obviously it is called as a snowflake schema, isn't it? Clear? Any doubts? Right. So now, sometimes what if this particular relationship is not built automatically when you create this data source view? So how we are going to create that? See, if there is no relationship between fact table and your dim product, what will happen? Someone has deleted it. Let us say, let me delete this. Delete relationship. Yes. Now, if I want to analyze, see, this fact table will have what? Facts information. If you go to the order quantity, see, I can show you that. See, we have sales amount, order quantity, all information is available here. So if I do not have relationship between dim product and the fact table, so tomorrow my manager comes and asks me to analyze. No, he will not come to me directly. He wants to do ad hoc analysis by connecting to the OLAP cube. And if he wants to analyze the data, something like this. So what are the top 10 products in a specific category? In bikes category, I want to see what are the top 10 products performing well, sales amount wise. So he wants to drag those items, but he will not be able to do the analysis. He will not get any information because you are not connecting this dim product to the fact table. So you will not be able to analyze the sales amount category wise because you want to do category wise sales information, right? So you will not be do that because it is not, nowhere connection is established between both the, no relationship between both the dim product and fact table. So you should make a join. So how you are going to join? Based upon a common column. What is the common column? Here you have product key. Okay, here you have product key and here you have product key. See, in dim product you have product key as a key column, primary key column. Here you will have product key as a foreign key column. So let's make a join. Right click on this header, table header, select new relationship. This is your source table. That means foreign key table. Okay, this is your fact table. Foreign key table means your fact table. And destination table is what? Dim product. You can select dim product and here you will select fact table. And what is the column? Both are having product key column only. Select the product key. That's it. So click on OK. Join will be created. Simple, isn't it? So like that you can make a join. After establishing the joins, then probably you can create the data source view. So once the data source view is perfectly created, then you can go ahead and create the dimensions. Okay, so before creating the dimension, I want to tell you one more thing. See, I told you fact table is connected to the dim date table 3 times. Okay, so this dimension is connecting to the fact table 3 times, more than one time. That is the reason why we call it as a role playing dimension. And here, if you want to see what are those 3 columns, first one is order date key. In dim date we have date key, in fact table we have order date key, and one more due date key with the same date key, and one more thing is ship date key with the same date key. So it is going to join 3 times based upon these 3 columns, right? Now let's go ahead and create a one dimension, new dimension. First one is product dimension. Okay, so we are going to build product dimension. So let's use an existing table. Click on next. Now let us select the dim product from the main table, and the key columns automatically it's been selected as product key. Product key is having the primary key column constraint. That's the reason it is selected. Now click on next. See, related tables are there. Dim product subcategory and dim product category, these two are connected to the dim product table. That's the reason why automatically these are selected. So let it be selected. Click on next. Now select the attribute names, nothing but column names. So whatever columns that are really, whatever attributes that are really helpful for you in order to do the analysis, only select those columns. Do not select unnecessary columns if it is not really helpful for your analytics. Okay, in your report or in your analytics purpose, you are not using those columns, then do not select them. It is overburden again. Okay, so product key, this is a key column, it should be there. If you go like this, see, in subcategory table also product subcategory is selected, product category is selected in the category table automatically. So let it be like that. Now select English product name. Let me select product color. Let me select model name. That's it. I don't want rest of the columns. I want to do analysis based upon the color, which color of products are moving faster, what type of model are moving faster, something like that. Okay, I don't do rest of the columns. Now from the subcategory I want to select English product subcategory name. From category table I want to select category name. Click on next. Now see, it is providing dim product as a name, so let me keep the same name. Click on finish. The moment you click on OK button, it is going to create a dim product. Dim product is a dimension. Dimension has been created with the selective attributes. See, and this is called dimension designer. This window is called dimension designer, and you have 4 areas, 4 tabs under dimension. First one is dimension structure, and second one is attribute relationships. Third one is translations. Fourth one is browser. Okay, in dimension structure again 3 areas are there, 3 pans are there. First one is attribute pan, hierarchies pan, and direct data source view. For this particular product dimension, what are the sources which are available? First source is dim product subcategory, dim product category. From these tables only we are getting this information, right? So that's why it is showing the data source. Hierarchies we need to create. I will explain it later. Attributes pan is showing whatever selective attributes are there in the previous step. So we have selected them. Perfect. Now let's come to the tabs. Okay, so do not think about attribute relationships and translations now. Let me tell you later. Now let's come back to the browser. This browser tab is used to testing purpose. This is purely for testing purpose. So if you are an end user, after deploying this OLAP cube, how you are going to view the data? You don't know. So every time you need to test it whenever you do modifications to the OLAP cube. So for that testing purpose, we are going to use browser tab. But it is going to give you error, right? See, it is going to give you error. What is that? Either the user Sudhakar or Sudhakar administrator doesn't have access to the SSAS class 23 database, or the database does not exist. This is the error. So we have created a project called SSAS class 23, but there is no analysis services database that is available with the name SSAS class 23. Okay, so first point is not correct. Do not have access to the SSAS class 23. We haven't created it yet. So how come we get the access to the database? So how we are going to create the database? If you right click on it, if you go to the properties, you will be able to see the deployment tab. In deployment tab, you will have a database name called SSAS class 23. This SSAS class 23 will be taken by the project name. So it will take the project name as a database name, but it hasn't yet created. Okay, not yet created. We have to create this first. What is the server? Localhost. Otherwise, you can provide your server name, Sudhakar. Okay. Now, change the what is the processing option? Yeah. Let me select do not process. Let me select the processing option, do not process. Click on apply. Click on OK. Okay. So the moment you right click on it and process, not process, sorry. The moment you click on deploy, then what will happen in backend system is going to create a database called SSAS class 23. Okay. Structure will be created in that database. It is going to connect to the analysis server database, analysis server. Then it is going to create SSAS class 23 database. Under that database, it is going to create data source view, and dim product dimension. Whatever we have created so far, all this information will be created in the class 23 database. So let me connect to the analysis server first, then I'm going to show you. See, we can connect from here also. Let me select analysis services database. Server type should be analysis services, and provide the server name. My server name is Sudhakar. Click on connect. Currently we are connecting to the database engine. Now we are trying to connect to the analysis services. Analysis services should be on. Services should be on. Otherwise you will not be able to connect to the server. See, we are connecting to the Microsoft Analysis server. So one node is there, databases. Expand that. Are you able to see SSAS class 23 here? No, right? So class 23 is not here. That is the reason it is throwing an error. So let me right click on it and deploy. So it is going to create a structure for us. See, it is deploying. Deployment completed successfully. Okay, it shows you message here. Now let us refresh it. Now see, you will be able to see the SSAS class 23 database there. So if you expand it, under data sources you have the AdventureWorks. Under data source view you have the AdventureWorks DSV. Under cube nothing is there, we haven't created. Under dimensions we have dim product. Clear? So by deploying it you have created the structure, but it doesn't mean that you will be able to access that, because you are not having any data. You created the structure only, but no data is available in that structure. So what we need to do, we need to say, let's click on reconnect. Still it is throwing an error. See, this time it is not throwing the same error. Database is not accessible or not available, because database is available. This time it is saying the dimension does not contain hierarchies. Ensure that the dimension has been processed. This is important. Ensure that the dimension has been processed. That means it should be processed. Processing means data should be loaded into the dimension. From where you are going to load the data? From your source table.
Okay, processing means you are transferring data from your source table to the dimension table. So whatever dimension you have created, that is only structure, no data is there. Right click on it, process it. It is going to open a window like this. The moment you click on run, it is going to copy the data from your source table to the dimension. See, process is successed. Okay, succeeded. I can simply close this and I can continue with the class, but I want to show you something really important to you. What will happen in the backend while processing the data? How it is going to extract the data? See, if you expand this plus symbol, lot of attributes are there, right? So just give me a second. Right. So if you observe clearly, this dimension attribute all completed. All is a default attribute member. Try to remember default attribute member. So what is attribute member? Data that is available in attribute is nothing but a attribute member, right? Let us say for product category name attribute, you have some data, bikes, accessories, clothing. These are all attribute members. Okay, so like that, one attribute member, default attribute member will be created. All is the default one. Okay, so do not worry about this. Let's come to the color attribute, English product category name, English product name, subcategory name, model name. If you observe this, these are all attributes which were selected by us at the time of creating the product dimension, isn't it? These are all columns. Okay, so it says attribute color completed 11 rows have been read. How you are reading those 11 rows? Expand this. Yes, there is a SQL query. How system is going to take the data? Using the SQL query, it is taking the data. Expand this. See, this is the actual SQL statement that is run behind the scenes. You can copy it. Copy selection. Go back to your database engine. See, we have already connected to the AdventureWorks DW 2012 here. Under SSAS queries, I put the comment like this for your reference. Let me paste it here. See what it is writing? It is getting the information for color attribute from the dim product table using distinct key. This is really important. If you execute this, how many rows you are getting? 10 rows, right? Okay, so 10 rows you are getting. What if I remove the distinct keyword? Let me uncomment it. So when you uncomment it, it will not be executed. Okay, if I execute like this, how many rows I'm getting? 606 rows we are getting. That means black is multiple times it is appearing here. Silver is multiple times appearing. Blue is multiple times. That means you have a lot of duplicate values. If you implement distinct keyword in the select statement, what will happen? It will remove the duplicate values. It is going to give you only unique data. Clear? So always in backend, system will use the distinct keyword for any query. See here also for English product category name. Actual categories, how many categories are there? Only 4 categories are there. Okay, if it is not using the distinct keyword, what will happen? So let me copy this. Because each and every product transaction will have some category information. So like that, how many transactions are there? Lot of transactions are there. If I execute this statement, I am getting only 4 column names, 4 category names. These are unique. If I remove this distinct keyword, if I remove the distinct keyword, oh, okay. See, this table actually, dim product category table will have only actual category names. It will have only 4 records. That is the reason why even though you remove the distinct keyword also, you are getting only 4 records. So if you go to the product name, then it will give you how many lot of product names are there, right? English product name, sorry, subcategory name and model name. Yes. So let me copy this, because each and every product will have some model information. If you execute the original statement, it will give you 120 rows, unique one. If you remove the distinct, see 606 rows are coming. Some of them are nulls, some of them are having values. See, some of them are having values. So we need to understand this point. Each and every statement will have distinct keyword because it plays an important role. So this is how it is extracting the data from the source table, and it is going to load the data into the dimension table. Let's close this. Let's close this. Now data is available. Whenever you process the data, in order to whenever you uh, change the structure, then you have to deploy it, then you have to process it. Okay, after doing those two things, you have to click on reconnect, then only it will show you the updated data. See, now it is showing the data. If you select color, see, all is a default parent level. We call it as default parent level, or whatever items that are comes under all will be rolled up to the all level. This is default parent. So we haven't created this hierarchy. This is a one type of hierarchy. See, when you have plus symbol, that is hierarchy. Okay, all is the default parent level under which you have children. Individual items are children. Okay, unknown is the default member. Unknown is the default attribute member. In your list, you do not have this. You have only 10 colors, but the 11th one is what? Unknown. Unknown is a default attribute member that is added to each and every attribute. Okay, so all these values are rolled up to the default parent called all level. Simple thing. Now let's come to the English product category name. See, we have only 4 categories. Unknown is a default one, like that subcategory. 37 values are there, right? So we are getting the data good, fine. Now we will test the data something like this using browser tab only. Now how about the hierarchies and all? So how we are going to create the hierarchy? Okay, so let me show you on simple hierarchy. So we know product category. Okay, let's I forgot to tell you one thing here. So let's keep the hierarchies concept aside. Now what I want to do, I want to show you something really important related to properties. Okay, so here we have category name and product category key. We have product name, product key, subcategory name, subcategory key. So this category is nothing but, category key is nothing but what? It is a ID column, primary key column. So whenever primary key constraint applied on that particular column, it helps us to uniquely identify each and every row in that table, isn't it? So no duplicates will be found in the category key generally. So category key is nothing but again category name only, right? So rather than having two columns in the rather than having two attributes separately in the same dimension, what if I delete this category name, and if I apply this category name as a named column for the category key, then it would be simple. So even burden will be less on the analysis server. No need to unnecessarily keep the same information, isn't it? So it will show you bikes, it will show you one. So one is nothing but bikes only, right? Simple thing. So if you go to the browser, if you select the category key, it will show you 1, 2, 3, 4. But user doesn't understand what is 1, what is 2, what is 3, and what is 4. So in back end, ID column will play the key role. In front end, if you apply the category name as a named column to this particular ID column, so when user sees the data, in front end it will be shown as bikes, but in back end, one will be playing as a role. ID will be playing as a role, key role. Okay. So rather than having category key and category name separately, what I will do, I'm going to delete category name. I'm going to delete product name. I'm going to delete subcategory name. So I have only color, model name, category key, product key, and subcategory key. Now what I will do, right click on product key, product category key, and go to properties. See, these are properties. So here I will come to the name property and I will remove the KUI key. I'll simply say product category. That's it. I will come to the key columns. Key columns property will show you the ID column. Okay, what is the actual ID column in backend? So let's click on this ellipsis. See, it is showing product category key. Fine. Now name column. Come to the name column property and click on none. See, currently it is none. Nothing is there. Nothing is selected here. So let's come here. Select the English category name because we want to assign English product category name as a named column for the category key column. Okay. So this is ID column and this is named column. Select this category name, click on OK. See, simple thing. So right click on product key, do the same thing. Go to the name property. Let me remove this. Simply product. Let's come to the key columns. In key columns, we have product key. That is the backend column. In front end, I want to select English product name and click on OK. For the subcategory also, go to the properties, change the name property. Let me remove that key. Go to the name column, select English product subcategory name, click on OK. That's it. Deploy it. See, we made changes. So whenever you make changes to the structure, make it deploy. After deployment completed successfully, you need to process the data. Select process. Run. Again, same story. It is going to execute the statements and it is going to get the data. Like this. Close it. Close it. Now go to the browser. Now see, still you will be able to see product category key and product category name. Why? We have already deleted a category name separately. Okay, but still why it is showing like this? Because you haven't clicked on reconnect. Click on reconnect, so data will be updated. Select the product category. So I have only product category, subcategory, and product. That's it. The moment I select product category, it is showing the bikes, components, clothing. But what will be the actual column? In backend, the actual column will be ID column. But in front end, when user sees that watching the data, he will be able to see the actual names. This is named column. Okay. Like that for subcategory also, same thing. For product also, same thing. Clear? Now, let's come back to the hierarchies and we are going to create one hierarchy here. Let me drag the product category. The next level would be subcategory. In subcategories, we will have products, right? So product will be the lowest level. This is called granularity level. Okay. So let me provide name here. Go to the properties, change it. Product hierarchy. Name it as product hierarchy. Simple. Close it. So let's deploy it again. So whenever you deploy it, or again you have to manually select the processing, isn't it? See, deployment is done. Again, you have to right click and you have to deploy it. So rather than doing it separately, the moment you deploy it, automatically it has to process the cube. So if you want to do like that, then go to the properties, go to the deployment. Here we have selected do not process. Let's select the default, then click on apply, then click on OK. So automatically the moment you deploy it, automatically deploying and processing both will be done. See, so no need to deploy it separately. Automatically it will process as soon as deployment completed. Go to the browser, click on reconnect. Now check this. See, there is a pyramid symbol for the product hierarchy. Select that, expand it. See, it looks like a drill down effect. Okay. In SSRS, tell me how many steps you have done. You created the row groups and you created visibility. You hired some items and you shown some items based upon the availability. So a lot of expressions has to be written, right? But here simply you drag and drop. You created a hierarchy. Now if I want to dig the information for bikes related subcategories, see, again cascading effect. Only bikes related subcategories will be shown here. If I want to expand mountain bikes, only mountain bikes related products. Clear? So this is what the advantage of OLAP cubes, hierarchies. Clear or any doubts? Right. So let's stop it here. So tomorrow we are going to continue with how to sort the data and how to create custom sorting. Then we will see attribute relationships and translations. Clear?